Hey, and we're back again. Once again, it is Mr. Spinks. Welcome, NAMS class, to the last set, or the last video of section 2.1. This is the fourth one you're seeing, and we're describing sets still. So, starting off with cardinal numbers of a set, or cardinality. That's what we're talking about here. Now, the cardinal number of a set, and which is symbolized N of A, is the number of elements in set A. Simple. Easy, easy, easy. Okay, so that's cardinality, number of elements in a set. And you saw this notation, the N of A, when we were talking about equivalent sets. It's the same idea. Number of elements is cardinality. So we're going to come to the next example. It says, what is the cardinal number of the following sets? Now, in order to do this, you're going to count the number of elements within the sets. It should be hard here. We're going to count 1, or 2, or 3, or 4, or 5, and there's 6 of them. So what do I write? I say the cardinality of number of elements of set H is 6. Easy stuff. Not hard whatsoever at all. Moving on to the next one, we've used a little set builder notation to help you to understand this. Now, I'm going to write this in roster form real quick just to make sure we get it and makes it a little bit easier. It is natural numbers that are less than 10. Well, natural numbers are not 0 and not negatives. They've got to be positives. So we start with 1, 2, 3, 4, 5, 6, and a lot of times with set builder notation, writing them all out can help if you're struggling at all. And 10, and you stop and you go, is that right? But hold on now, our set of natural numbers is less than, not less than or equal to 10, but just less than. So the 10 doesn't count in this case. We will end it at 9. And if I look at that, now I can count them. All right, 1, 2, 3, 4, 5, 6, 7, 8, 9. It's a total of 9 of them. So the cardinality or number of elements in set F is 9. Easy stuff, not hard. That's the concept of cardinality. Next, we're going to talk about one-to-one correspondence. So, for two sets to have 1-to-1 correspondence, a couple of things have to happen. They have the same cardinality. That's first off, same number of elements. And second is each element of one set can be matched to an element of another set. Okay? It's kind of the idea, one-to-one. They have the same number of elements and you can match them. They have a match within their sets. Okay? And we will use a couple of examples to help illustrate this for you. Alright, so let's take a couple of sets in this case. Let's take set A. And set A is going to be, oh geez, I don't know, we're going to go with North Carolina. We're going to go with Georgia. We're going to go with South Carolina. And we're going to go with Florida. And we got another set in this case. Our other set we're going to call B. This set B is the set of, and we'll go with Columbia. Next one we've got is Raleigh. Tallahassee. And Atlanta. Now, these are one-to-one because number one, they have the same number of elements. They each have 4. And I can match each one to the other one. Like, for example, the capital of North Carolina is Raleigh. Those two match together. Capital of South Carolina is Columbia. Those two match together. The capital of Florida is Tallahassee, and the capital of Georgia, whoop, is Atlanta. That's one-to-one correspondence. Not only do they have the same number of elements, but we can match one of one set to one of another set. Okay? In another example, draw out two one-to-one correspondence for these sets. Well, we have set A, which is A, B, C, and D, and we have set B, which is 4, 5, 6, and 7. Now we have no prior knowledge, so let's just say that A matches to 4, B matches to 5, C matches to 6, and D matches to 7. That's one example of a one-to-one correspondence. But it doesn't have to be that way. Let's say we had the same sets, right? And we do a different one-to-one correspondence in this case. One sec, let me set it up. 5, 6, and 7. So let's say that A matches to 5, and B matches to 4, and C matches to 7, and D matches to 6. Notice they're still the same number of elements and they still match, but it's a different matching, so it's a different one-to-one correspondence. Two final things to talk about. We've got the empty set or null set. The empty set or null set is the set that contains no elements. This can be symbolized as, we can do it as an empty set, so that's just basically set of braces with nothing in it, or 0 with a line through. Is basically what we've got there. Moving on to the next one, we have the universal set and its significance. Well, the universal set and it is symbolized with a big U, so it shouldn't be hard. It is the set that contains all the elements for any discussion. Easy stuff going on right there. That's the universal set. Okay, so as we look, we're going to go on to one final example, and this is the last example, and this example is for you. It's an Algebra 1 example. You are going to complete this example and have it ready for me when you come to class tomorrow, and I will check it. Otherwise, this was our last video for Section 2-1.